They do the drawing. Then that drawing again comes to architects. They merge or combine the drawing. Then they send to the contractors for execution of the site. So this process is tiresome and also lengthy process. And also the engineer cannot start until the architect finishes his job. So here with BIM, what happens is, say, let's say the project is 100%. If an architect does 20 to 30% of his job, like a bare skeleton is done, the engineer can directly start the work from there because this is a central model and everyone has access to the central model. So whenever the architects are doing 10 to 20% of the job, the engineers can straight away plan their job from there only. You don't have to wait for the file from architects to receive and also start from there. And also, this is less prone to error because everyone is loading into the central model and there is no like you did not send the file, I did not receive the file, this is not the updated file, this is not like a previous, you have done the work on previous version. These things cannot be said here because everyone receives the most updated file and also we know what file we are working on, what is that version of that file, and also when that file is updated and also who has worked on the file. So there is no escapism here. You can actually track and predict and who the work is done and like what is the percentage of work is done, everything can be tracked with this central model. It also helps to efficiently design the building. So efficiency comes in a way that say there is a, column and there is a duct passing and there is a clash between the duct and column. So in a typical scenario, what happens is both the team from the structural engineering and also the HVAC unit has to sit together and also solve in the site, right? So but with
Correct.
this, yeah, but with this Revit, what happens is we do something called clash detection. So once the modeling is done by both the structural engineers and also the HVAC engineers, these models will be interfered with each other or like checked with each other, both the models, and they'll find clashes. Wherever the clashes are there, the clashes will be noted by the software itself. And then the modelers has to go to that particular location and discuss beforehand, like who has to go down or go side at what is the possibilities, and then again they'll rectify, again they'll do the clash detection. Likewise, say if there are 1,000 clashes in this particular model between the structural and the MEP services, they'll rectify until clashes are minimal, and if at all there is a clash, that should be okay in the site. Until then they rectify, then they pass the model to the site. So this what happens is there'll be no wastage of time in the site because of the clash. So thus, our model will become more efficient as well as we are going to save a lot of cost or time regarding the corrections. So it also enables architects, engineers, and contractors to collaborate and in real time. So there is two concepts here: collaboration and coordination. Collaboration is, say, here we have architects and engineers who are like from different fields. They have to collaborate on the same project or the same file. You can divide the file between them, and also at the end of the day, everyone's work can be loaded in the central file. That is what collaboration is. Then what is coordination? Say coordination is the same team people may be working, like in the architecture firm, the company may have 20 employees. 20 employees may work on the same file, and at the end of the day, all the work should be merged, right? That is called coordination. So with BIM, it enables these all the stakeholders to collaborate and coordinate. So some of the advantages, as we've discussed, it saves costs and also it improves the efficiency. The errors will be drastically reduced, and also we have better project outcome because of this usage of BIM. So here, this is an image that demonstrates how this BIM works. You can see there are multiple disciplines. Everyone is working on their own, like someone is working on facade, someone on structural engineering, someone on, say, some other MEP services. They save the model in the central file. So whenever someone from this team have to access, they can access from the central file and also they can work on that. So at the end of the day, everyone is going to save the central file. You can see gradually the project is going to be completed with full-fledged, starting from design to build and then operate also. So you can see they can have access in the site as well. If the project manager want to see the tab or say the phone, they can access this same data anywhere, anytime. And someone is going to walk in the site and they see an error, they can immediately open the model and they give the correction then and there. This correction will be directly sent to our team, design team. They will see the correction or they will see the error. They will try to rectify again by sitting with all the stakeholders. So this is a real-time environment, how the BIM is going to function. So what are the trends that BIM are going to adopt with? You might have heard about VR and AR, right, sir? Right now, the only way to show the customers is like you can make a 3D model and have a good render or a video and then show. That is a current trend. But with the BIM, you can actually show the actual model with the help of VR headset to the client so that they can have they can have the feel how the building is going to look when it's being completed. They can really see with material and they can have the walkthroughs also. They can have an immersive experience of how it feels when the building is completed. And also we can see currently there is no chance of seeing 3D model in say your phones, but with BIM you can access the 3D models in your mobile phones or in your tablets in the site, and also give the corrections to the design team which is sitting in the office. Also, you might have seen the laser scanners in the construction site, or when we measure. These data can also be sent to the BIM for perfection, like whether the building is correctly sitting as per the dimensions or not, can be measured. The last part are sensors. These sensors, when the construction is happening, can also predict about the safety and also the dimensions, as well as the sensors can be fitted when the like the building is completed, and you want to say adopt these sensors in a way that it will give us a factor of safety. Like say you can fit a sensor in a room, or a sensor in a room which has a HVAC connection. That sensor can be directly linked to our 3D model. So if in case that HVAC is happen to fail or is going to fail, that sensor will be triggered and the trigger warning will be sent to our model. And from there, the information can be directly sent to the maintenance department so that they can eventually easily find out where the error is and rectify the problem. So this makes the work easier. So for whom this Revit is going to be useful or the BIM is going to be useful? For architects, engineers, all the engineers, the construction personnel who are in the site, contractors, and the cost estimators whose only job is to take BOQ. They can also immensely benefit from this BIM, and the site engineers. So how the BIM workflow happens? So what is the start to end process? First thing you have to do in BIM is, as like any process, you have to conceive the model. So how this thing is going to look, a rough sketch or a detailed sketch. Then based on that sketch, you have to add more information to the model. Then for that model, we have to perform the optimization, which is clash detection, or if it is a HVAC, you have to perform calculations for equipment placement, and all this optimization takes place. Then after all the steps, we have to document. Document is nothing but preparing the sheet so that it can go to site. So this is the workflow: conceive, model, optimize, and document. There is a software that does all these 4 steps. That software is Revit. So Revit is the software that helps us to achieve the process of BIM. So BIM is not Revit, Revit is not BIM. There is a huge difference. So Revit is a software that enables us to achieve the process of BIM. Why do we use BIM, Revit? We use Revit because most of the construction personnel in this world are familiar with AutoCAD. So Revit is based on AutoCAD. 80% of Revit, the main core architecture of Revit is based on AutoCAD. So anyone who has knowledge on AutoCAD can easily adapt it to Revit. So the first reason or first process that we use Revit is it integrates multidisciplines. So as we've discussed, structural, mechanical architecture, all these disciplines can be integrated in one platform. So if you buy one software that is Revit, all the platforms will be in it only. You don't have to do it separately again in other platforms. So it's combination of all the disciplines. And also the process of designing is intelligent and parametric based. So if you want to place a wall, say the wall has automatically properties inbuilt in Revit. So you have to just take the command and draw the wall. The wall will be there. You don't have to take a line and offset it line and again place it in the layer in which it has to be there. These things will be manually done in AutoCAD, but it is automated in Revit. We can generate floor plans, elevations, sections, all the things can be generated with a single button or with a single code. You have to model for one thing, like you have to, if you're modeling in floor plan, the plan will be simultaneously generated in elevations, sections, and schedules as well. So then comes the advantage of analysis. So you can do the model only once, like say this is a model. This model can be sent to analyzation, say for a structural analysis, this model can be sent. And also this model can be sent for lighting analysis, how much lighting this building requires, and also heating and loading. All the things can be performed on this model itself. And also visualization for 3D rendering and all, you can push this model itself. So this is the advantage to it. So this particular tab represents how architectural palette looks into it. So these are the tools or these are the possibilities that we'll discuss further in the software. So this is a structural environment where you can go up until this level of detailing in Revit structures. And this is the services environment. You can see there are a lot of ducts and machines going on. This level of detailing can be achieved in services environment, all in one software. So now let's go into Revit and see the software. So you have any doubts until now, sir?
No, sir, everything is clear.
Okay.
Shall I have this
Yeah.
PPT presentation?
In the last day, I'll give because I did not prepare for every day.
Okay,
Maybe
no
in the 10.
problem. Yes, sir.
Okay. So,
Okay.
so this is. I'll just close this one also. So when you open Revit, this is what you'll be greeted with. This is called as graphical user interface. So same as AutoCAD. There is no change, but we have two additions, that is recently opened files, recently opened families. So we are not going to discuss about this. We'll see this later. We'll see these files. These are the files that we are going to access whenever we open Revit. Like say this is a file you have recently opened or recently used, that will be displayed over here. So in the models category, whatever we do in Revit, it's called model. Whatever we do in AutoCAD, it's called drawing, right? So that's the basic difference.
Yes.
In AutoCAD, we call it drawing. In Revit, we call model. The
Yeah,
format
it is
of
format.
yeah, the format in Revit is called .rvt. In
.rvg.
RVT. I'll show that, no problem. So if you want to open a new project or set a new project, you have to set a template in Revit. Just like AutoCAD, you have to set a template. So in order to set a new template, because the file may be, you may be working on MEP discipline, you may be working on structural or architectural discipline, the system has to know. The system will set the default template so that you can work whatever the discipline you are in. For that, because we are in practice, I'll just show the default template, how you are going to set. I just go for new. As soon as I go to new, you can see this is a new project. Here, it definitely asks for a template which you are going to work on. You can select this drop down or you can just go for browse. If I go for default metric, I'll be covering with all the default settings in the template. So I'll just go for default metric. But here you can see there are a list of disciplines that are there. Here and here as well. If you're working in architecture, you can select this template. If you're working in mechanical systems, you can select this template. But right now, I'm just in practice session. Just go for default metric. Metric is nothing but meters. The units will be in meters. You can change in the software also, but when you're selecting the template, you can select either meters or inches format. Here, I'm just going for default metric. So we have selected a template, and The templates format is .rte and hit OK. So same as AutoCAD, this is our drawing area, right? This is our drawing area. This is called as ribbon. And we have two tabs over here. We'll see that later. First, this is called as elevations. So since you're working in construction, you know what elevation is. This is our north, south, and east and west. So we have 4 elevations. So one golden rule is whatever we draw, we should be drawing in this area only. If our drawing is big, let's say I'm trying to draw a wall. If our drawing is big, let's say this is 3800 mm. If your drawing is even bigger than this, you can just select this by right clicking and drag it. You can drag this elevation. So by that, you can actually drag that elevation and delete it later. If your drawing is big, wherever you think your drawing is there, you can extend this elevation. It just works as a camera. You don't have to worry about this size and proportions and all. You can place it anywhere. It just works like a camera. Okay, so that is what elevation is. And if you want to go for an elevation in your project, you have to use this project browser. So what project browser is it will highlight wherever you are. Say, for example, we are in level 1 in our project. This is a default template, and I have taken the default template. So here you can see we are drawing floor plan, and in the floor plan, we are in level 1. That is why level 1 is highlighted. So if you go to any elevation in the project itself, I'm not going anywhere. In the project itself, if you go to elevation, you can see east elevation is highlighted. And the east elevation, what you're going to observe is the 2 levels, level 1 and level 2. Suppose if you delete this level, is it possible to redraw the level? Yes, it is possible. Let's see how you can redraw the level. So just make a note. Levels can only be created in elevation. So if I go to level 1, I cannot create one more level. Say building is like 5 floors, okay? So for that, you have to create multiple levels. But if I am in levels in the floor plan, I cannot create one more level. For that, I have to go to elevation, because in the elevation only we can see the height, right? In the individual floor plan, we cannot see the height. So this is level 1. This is level 1. That is 0 of my building. That is base. And if I want to go up or down, I have to start from here. For that, I will go for datum section. In the datum section, I can see levels and grids. I'll take levels. The levels can be drawn with 2 options. One is line, the other one is pick line. Let's see what is line. So for line, if I take this line command, it will automatically base from 0. You can see as I go up, you can see the height. If I want to draw a level at 4000 mm, just scroll it until you reach 4000. Click wherever you want. You can just see the height. No problem. You can adjust the height later also. How? Just double click on this 4100. Make it 4000. Likewise, you can adjust the height. That is first method, which is manual method. The second method is just take this level again, go for this pick line option. You can just give the height offset. Let's say next level is again 4000. If you think, or if your project's next level is 4000, take 4000. As soon as you go to any level, there will be dotted line indicating the offset height is 4000. Likewise, you can create multiple levels. So these are the 2 methods to create levels. So here you can see I have created 1, 2, 3, 4. 1, this is 0. Level 1, that is 0, 1, 2, 3, 4. 4 lines. So I have created the levels, but the naming is wrong, right? After level 1, level 2 should be the level 2 we have deleted, but the software is still taking from level 2 itself. If I want to change the level, I will just double click on that particular level. Now remember, sir, you have to always start your levels naming with numericals only. Why? Because if you change your level with alphabets, what happens is it will here it will be showing perfectly, but here it will be arranged as per the alphabetical order. We don't want that. So you have to always name these levels in the form of numbers only. 0, ground floor. Would you like it have a dialog box? Just click it and hit S. Then double click here, 0, 1. First. So double click here, 0, 2. You have to do this manually, only this thing. Again here. So 0, 4. We have 4 floors. So this I have created in east elevation. So let's see what happens if we go to north elevation. You can see in the north elevation also, all the levels have been repeated. All the levels have been reproduced, right? So here I have done in east elevation, but you can see no matter which elevation I go, these levels are there. And also the floor plans for the levels also been created, right? There will be nothing in the floor plan, but we have created the floor plans while we create the elevation levels in the elevation. So that is what our project browser does. A project browser indicates where we are in the project, and also wherever we are, that will be highlighted. So here right now I'm in east elevation. So you can see we are highlighted here. As soon as I go to any floor plan, you can see that will be highlighted because it indicates where I am. That is a function of project browser. Now let's see what the properties tab is. I'll just take a wall, simple wall, draw like this. As soon as I hit on this particular wall, you can see the properties bar indicates what are the properties of this given wall. This is a wall of 200 mm. Okay, this wall is traveling from ground floor. If you want to change the properties also, you can change. Let's say this is 0 from ground floor. If it is going to travel until first floor, you can change it over here. This wall is traveling from ground floor. It is traveling up to first floor. The height is 4000 mm because there is a 4000 mm height here. So the system is automatically considering the height as 4000 mm. And also let's see what are the other properties. You can see its length, its area, its volume. All the information related to the particular wall is being denoted here in this properties bar. So a properties bar indicates all the properties of that particular element, whatever the element is. So that is what properties bar is. And if you open the project, and you don't see the properties bar in project browser, how do you take it? Just right click. Right click. Browser, project browser. For the project browser, right click properties for the properties bar. So you can move it, change it, or place it as per your convenience. There is no fixed order for this properties bar and project browser. You can place it wherever you find convenient. So that is what our properties bar and project browser does. If you want to set the units in your project, just press UN. You don't have to press enter. So if you're coming from AutoCAD to Revit, just remember that you don't have to use your keyboard that much. So press UN, that's it. Mostly we are habituated to enter after pressing any command in AutoCAD. Here, yeah, you don't have to press enter. Just press UN. You can change the angle, area, or all the properties related to this particular units. You can change it over here. Once you're done, you can just hit OK. So that's simple thing. And you don't have to remember any command in Revit. You can create your own commands also. The only command you have to remember is KS. That is keyboard shortcuts. So here, if you forget any command, it will be here. Or if you want to change the command properties, right now I said right. So the command is PP. If you want to remove, you can remove. If you want to place like your name US, like whatever the command that is favorable to you, QW, whatever the command you want to keep for properties, you can keep it here. There is no fixed command. You want to change, just remove and assign your own. So let's say this is not there. Just press PP, it will be there. Likewise, you can assign all the commands as per your wish. There, you don't have to remember any command. So that is the GUI. Let's see the ribbon tools. So these are the tools that we use for modeling the architectural elements. These are the tools that we use for modeling the structural elements. These are as well, like precast, steel for all the connections. And then these are the tools that we are going to use for the systems, mechanical elements, ducting, plumbing, piping. All the tools we can find here. So as we discussed earlier, Revit is a combination of all the disciplines. So if I have done with my architectural modeling, I can send the file. Someone from the structural discipline can open the same file in the same software. So they don't have to use other software, and they can access all the files, all the tools related to their work area. Someone from mechanical discipline can take the architectural file and take that use that as a reference, and this is ducting work or terminals or mechanical equipments. All the things can be fixed on the same file itself. So it saves like they don't have to buy other software to this work. And also it enables us to say like everyone can say have work in the same platform. That is an advantage. So our scope will be we'll cover all the tools that are there in the architectural panel, and we'll cover something in insert, annotate, analyze, massing, collaborate, modify, and add-ins. So this one, and from here all the tools will cover. We will not highlight all the tools until system, structure till system, because they are from other discipline. So our scope is working on architectural part of the Revit only. Yes, sir. So this is a game step up of AutoCAD. AutoCAD, we have all the draw tools over there, right? Same way,
Yes.
here we have the build tools. In AutoCAD, say for example, if you want to draw a wall, you have to take a line, offset the line. But here, if you want to draw a wall, it's easy, and it's also more detailed, much more sophisticated way. You have to take this, go for this wall command. Since we are working in architectural file, I can just select wall architecture. Here, after selecting wall architecture, I can select this drop down, which has all the files related to the wall, all the type of walls that are available in this project by default. No matter, like say for example, to draw 200 mm wall, you can just select this particular
thickness,
wall. Yeah, wall thickness.
the thickness of the wall.
Not only thickness, the type of the wall. This is generic type of wall.
Oh.
If your wall is having a surface exterior different from interior, you can select this type of wall. We will dig deeper in, like I just wanted to explain basic. We can dig deeper also in these concepts. Just let me take this generic 200 mm wall. Okay, so I've selected my requirement is to draw 200 mm wall. I've selected this 200 mm wall. Now I can have to like describe whether the wall's dimension has to be based on its center line or finished face. Normally we'll put center line. Even if you want to take the external face for the dimension, like dimensional measurement, you can take this also. So that is an option. Like location line, which means if I'm drawing a wall like this, you can see, just delete this wall quickly. You can see as I draw a wall, there is a center line, right?
Yes.
The measurement will be from the center line. As I take the turn, you can see, sir, the measurement is having from the center line. So that is what wall center line is. From where you want to take the measurement. So if you want to delete, just select all and delete. So normal delete. Escape. Then if you want to come out of that command, like this is a command, if you want to come out of from that command, just escape. You will be coming out of that command. So I just want to draw a wall. 200 mm is my thickness. I'm drawing from center line. This is my base 0, and I want my wall to travel until first wall. Here, the top constraint, which is what is the top level of your wall. I'm going to select the first wall. So these are all the constraints I'm going to give for my wall. Then with all these tools, I can draw the wall. The draw tools present over here. If your wall is straight line, you can select this type of. If your wall is a rectangular wall, instead of selecting this, you can just select like this.
Okay.
Yeah, if your wall is a curved wall, you can select this type of wall. Just start, end, and give something like this. Here, the beauty here lies is I've drawn all these things in only 2D, right? So this wall I've drawn in 2D, and now let me just do this. Here you can see a cube. If I press on this cube and make it realistic, you can see whatever the property that is there for that material of that wall, it will be displayed in that particular property. So it's doing rendering also, and the realistic can be. And now see, I've done this wall in floor plan. Now if I go to any elevation, I can see the wall. Again, here also, if I take it from wireframe to realistic, it's in wireframe mode. If I take it to realistic, you can see how this particular wall that is in ground floor is going to look in this given elevation. You can go to any elevation, that particular wall will be visible. So here, you can drag this. If your elevations are not up to the drawing, you can just simply drag those elevations. There is no, just simply drag it. So now it will be there, but I just make it realistic. Now you can see the wall is there. The same wall which is I've drawn in floor plan, it's going to be visible in all the elevations. No matter which elevation I go, it will be visible. And if you go to 3D view, that is here, you can see a hut. If you click on this hut, you can see the 3D view here. And here also I'll make it realistic. You can see the wall is being generated. How this is going to look when you go to 3D. You can see I've worked only once. That is, I've done only once here. I've drawn. What the views I'm going to generate, I have generated plan views, I've generated the elevation views, I've also generated the 3D. For the same amount of work, I'm going to get the triple results. Right, sir? So that is the advantage of Revit. And if you want to take a section like here, from here, how does the wall looks? Just take this section from draw like this. This is your sectional range. Here you can see there is a section dialog next to 3D elevations. Just double click on the section. You will view how the building is going to look in that particular section. So here is a cut, right? So with one single effort, we are going to get these many types of results. That is the advantage of Revit. So I'll take wall again. So we can draw multiple types of walls and say, for example, I've drawn wall like this. And I know the dimension of this wall as I'm drawing. I just quickly change it to my phone. Now, if I want to draw a wall 90 degrees to this particular wall, as soon as I click in the center, you can see that is called grid. If I travel 90 degrees, that is denoted by an angle of 90 degrees here in the right side. And also a straight line, dotted line that indicates that I am traveling or I'm drawing a perpendicular wall to this given. If I take an angle, that angle can also be seen here. If it is 45 degrees, then also there is a notification that the drawing wall, which is 45 degrees to the base wall. You can see.
Yes,
Again, if I draw a straight line from this wall, if it is 90 degrees from the base point, it will show like this. So again, if I draw this wall, if this wall comes in contact or this particular point comes in contact to origination of this particular wall, there is a denoted dotted line that indicates that both heights are same. So this eliminates us to measure where the wall is there, or whether we are drawing parallel to this wall or not, whether we are making a joint or not. And one more thing, this here, the shortcut of the wall, and this is my first wall, and this is my second wall. As soon as I draw both the walls, there is a seamless joint.
Yes.
There is a seamless joint. You cannot see the joint here. Even in the 3D also, if you go to 3D also, you cannot see the joint. Even in 3D, if I go to wireframe also, you cannot see the joint. There is no joint, right? So that is what Revit intelligently finds out. This both walls are of same property, same wall type, so they can be joined. And the joint may not be visible because in real time also we cannot see the joint, right? So that is what. So, and there are multiple types of walls to draw. You can say we have drawn 200. Let's see how we can draw 140. Same 140 mm also. So of 140 mm. That is why it is displayed in that way. If I go to 3D, you can see the 140 mm has a pattern. That pattern is visible like this. So this is more realistic. This is not a generic wall. That is why it is. If you want to change the type of pattern here, that is also possible. You can add your own image, just draw it, and it will be displayed. That we'll see later, but I'm just telling. So these are the possibilities. Okay, sir.
Okay.
So there are plenty of commands that are there, but we'll discuss in the later session how we can draw different types of wall and how we can edit wall. Starting from tomorrow session, we'll just dig deeper and discuss all the other elements. I'll just turn off the recording.